We're on. We're on.
All right. Well, welcome everyone. You're tuning in to the Stanford AIMI Center's series on happy hours, where we just get a great group of people and chat and banter about all things machine learning and in medicine. This week, we're excited to have Hugh Harvey, Luke Oakden-Rayner, Judy Gichoya, and Sharon Zhu joining us. So hopefully this is a nice conversation. As always, we would love to make this as interactive as possible. So for any of the people tuning in on YouTube, please feel free to use the chat, post any questions that you have. We'll be constantly monitoring that and try to include the questions as we go along. Maybe to get started with, one question that I had for everyone here is, what's new? Have you seen anything new and exciting in the last month or so that has made you think twice or made you really want access to a cool new technology? We'd just love to hear what's out there and what I've missed.
Who's going to say it?
You do it.
Who's going to say it? It's for you, Hugh.
GPT-3. So I don't know.
How will it disrupt medicine?
Yeah, what's GPT-3? So GPT-3 is a language algorithm. That's not the best way to describe it. We'll get into details. It's built by OpenAI, who are a private company, and they've basically trawled the entire internet or the vast majority of it and fed it into a language model. And all it does in essence is try and predict the next word that should come after a word that's given it as a prompt. But what they've discovered is some incredible things, is that you can give it almost any prompt that you can possibly think of, and it comes out with, the vast majority of the time, reasonably sensible answers. And the applications so far appear pretty endless. It hasn't been applied to imaging yet, as far as I'm aware, but the language capabilities and the question answer prompts that you're seeing mainly come through on Twitter over the past week or so, to me have just been mind-blowing. And I don't know about you guys, but I spent every spare minute playing around and reading about it.
Yeah, Hugh, I wonder if you think GPT-3 has any sort of consequences or repercussions in how we do machine learning in the medical imaging realm. Because maybe one of the biggest takeaways that I've had from GPT-3 is not just that it works well, but if you build a big enough model, I think GPT-3 has 200 billion parameters. And if you train it for long enough, in like many TPU years, essentially, the models become few-shot learners. Do you think that will change how we approach or view medical research problems?
I mean, what I would love to see is you could take something like GPT-3, just that architecture. Imagine if we could take every single scan on every single PAC system around the world with every single report and the associated medical record and put that through something the size of GPT-3. The mind just absolutely boggles what it might be able to achieve there.
Yeah, I mean, we should point out here that people do this, that not in medical imaging, but in imaging in general, that transformer models and contrastive models and so on have now been applied to imaging as they've been applied to language models. No one's built as big a model as they have for GPT-3 now, but these models are applicable. And certainly we have vast stores of medical images now. So the idea of having a generally pre-trained, self-supervised medical imaging model is no longer as ridiculous as it was a couple of years ago. And that is really exciting, that the idea of having a few-shot learner in medical imaging would be absolutely groundbreaking and transformative.
This reminds me to a question I think that was asked in our previous happy hour series. And I think it'd be really interesting to get the perspectives of everyone here, because we encompass more technical machine learning skill sets as well as very clinical skill sets. But if you did have access to this like magical system where you had access to endless compute and data from multiple different hospitals, what is something that you would like to build with it? What would be your first use case? It's a hard question, because I was trying to think about what I would do with it first, and I couldn't come up with an answer, but maybe I just wanted to hear what other people's thoughts were. If you could build anything, what would you build?
Not Bone Age.
I thought that's the ultimate application, right?
You'd probably do what people are doing now with GPT-3, which is not just producing a model that can produce text after some prompt or something, but is producing a model that can respond to user needs. So, we've seen GPT-3 now being used to do things like produce code for people. So you type in, say, what you want a plot to look like and maybe where the data is, and it will produce the plot for you by producing the code that makes the plot. And so an example in medical imaging would be you have a universal pre-trained medical image model, and you don't need a massive labeling task anymore. You just give the system two users, and when they want an AI system to learn something, they can say, here's one example, and maybe from then on that system is fairly useful at that task. Or, I want to identify the levels of the spine. They do it on one case, and then every case after that is now solved. So, the idea of taking the expertise needed to train models or to do code or to, automate tasks and handing it off to users is something, that it still sounds like complete science fiction, but GPT-3 is achieving at the moment. So I think that's where the potential value lies in something that big.
Yeah. What are the coolest examples you guys have seen on the web in the past week or so?
Something cool. Go ahead, Sharon.
I think something that's really impressed me is that language kind of underlies many, many different concepts, and that language, you could use language for so many different things, and actually including images. So you could think of it maybe autoregressively, where like each pixel is just like the next word or next token in a sense. So I have seen some cool meme generators.
If you could build anything, what would you build?
If you can build a meme generator, you could probably cure cancer.
Perfect.
So please don't quote me saying that. I've seen some really great demonstrations of building those charts and graphs like Luke was mentioning, as well as just like building front end stuff for you, like a button or something like that, that I would personally take forever in CSS just to center. So that's fantastic. So I was really impressed with just the breadth of things. And like Luke was saying, just the fact that you give power to the creators, like to democratize it to like any creator, to just then fine tune it to your own needs. So that would be really cool to have doctors, let's say we had like a GPT-3-esque thing, and have doctors say, hey, I'm in X place where the resolution of things, of an X-ray is not as great or whatever, and I want to tune it to my needs so I could serve my patients, something like that. I don't know, but something very specific to the needs of a particular area or a particular type of person, that only they really, really know about. And I think that's really exciting.
I wonder if it's possible just to have an all-purpose model where it's seen, every modality, every type of image, and it's seen the associated reports. And the prompt is a new image it hasn't seen before, and the output is a full, complete radiology report. And that sounds like complete science fiction and scary. And my regulatory side of my brain says there's no way that would ever get through any safety net. But I think technically this is possible. If the network is large enough and has seen enough training data.
Yeah, I think similar to what Luke had mentioned, I think if we can use self-supervised methods, we can just help create this massive and well-trained backbone. And maybe that doesn't have to be the final model that you end up deploying, but if you now want to fine-tune it for a particular task of interest, since it's a few-shot learner, then hopefully the needs and requirements for data are a little bit lower. So you can still use that backbone to do what is it that you care about. I did find it interesting that both Sharon and Luke mentioned that techniques like GPT-3 can really help us customize needs. And I definitely wanted to introduce Janie to the group. I feel like in a lot of these happy hour conversations, we've talked about radiology, but I'm really excited to learn about something that I don't know too much. And Janie has a big background in, which is pathology. And maybe you could share what are some unique challenges and problems that you face in pathology, and maybe what's your sense of, the field of machine learning and how can it help you as a clinician in path?
Certainly. So thanks very much for the kind intro, Akshay.
Yeah.
Apologies, I'm a bit late. I actually thought this was starting at 3 p.m. So Sharon texted me and I said, oh my goodness, I'm on my way. So it's great to meet you all. I think, with regard to pathology, we're about 20 years behind radiology. And there are particular, challenges in terms of data acquisition because everything is not digital. And so we spend a lot of our time actually just trying to get large enough data sets to train on. And I think one thing that is quite exciting to us in terms of, I'm not sure if we're talking about GANs yet, but I was going to say the possibility of generating a lot of quote unquote artificial training data, right, in order to train these models adequately. Because for us, a large data set is probably something like 1,000 images. So that was one thing. As all the panelists had mentioned, also having a model that I think can adjust to user needs, right? So I would love to have something that can automatically, let's say, take a cancer specimen with 20 plus slides, look at all of them, and automatically generate a pathology report that contains all of the pre-populated fields that we need to report for cancer. And obviously a lot of this, I think it's still, perhaps not quite in the realm of science fiction, but I think it'll take a long time to get there. So certainly agree with the rest of the panel that, I think there's a common set of needs that we all have in medical.
I wonder if there's going to be an organization, whether publicly funded or private, that pre-trains an image-based GPT-3 just on ImageNet or internet images, and then we use that backbone, and then we can apply that to radiology, sort of fine-tuning data sets. I think that might have been what Luke was suggesting in his first response.
And I think there are ImageNet trained ones. Sorry, go Judy.
No, those are there, right? ImageBot from Microsoft. I think someone in the chat posted Image GPT. Those are there.
But they're not as big as GPT-3, right?
Yeah.
The problem is you don't have as much data. That the common crawl of the web for text is so vastly bigger. So many more examples than ImageNet. ImageNet's huge, but ImageNet is huge as a curated image data set, which is very different than sort of just grabbing all the text you can find on the internet. There are bigger image data sets that cover more of the internet, but they're also highly uncurated and contain a large amount of objectionable content and all sorts of stuff. And so, there's big challenges to trying to scale up images that you don't face as much when you're trying to scale up language. Although language has that same problem as well with objectionable content, the Reddit corpus issue. Yeah.
And I also wonder, would they work at the full resolution that we have? Because chest X-rays and mammograms are pretty high resolution images compared to what you find, on the internet when you've got cat pictures or whatever it is.
I was going to say when Jenny was talking that one of the big challenges in pathology, right, is you have gigapixel images that, we're complaining about having a few thousand pixels in each direction, and you've got these ridiculous high resolution microscopy images that, how do you even deal with them?
So we can't deal with the whole image, right? You're right. Each of these is, on average, anywhere from 500 MBs to, let's say, 5 or 6 gigapixels. And so what we do is we slice them actually into, we subdivide one large image into multiple thousands and thousands of smaller, let's say 256 by 256 pixel image tiles. And those are what actually get input into the neural network. And as you can imagine, there's a lot of pre-processing involved, and it is somewhat of a pain just to get to that stage.
And lots of labeling per subdivision, right? That you have to.
Yes.
Yeah.
Yeah. The manual labor, I think, is another thing. Not to say that pathology is, so much more work than radiology. Obviously, I think each specialty has its challenges. But I think for us, we're more so interested in particular tissue types and cells in an image. And so there might be, on a radiology image, one region of interest, right? Or one or a couple that you annotate. But for us, we typically, we're interested in individual cells and also counting those cells and being able to segment them. So we might have to label, thousands of cells just in one whole slide image. And so there's a lot of interest in having an algorithm that can sort of do some of that pre-labeling for us, which we then correct. It certainly, those things save us a lot of time.
Yes, having worked with Jeannie, we have hacked together interfaces for iPad segmentation, various patches. And it's quite remarkable how many patches you can get just from, let's say, like 10 slides. Yeah, and also I recall that with digitization kind of just emerging and ramping up in pathology, there aren't, I guess, as clear standards maybe. So then you can get essentially varying resolution, might not be the right word, Jeannie, but varying, it does look like varying resolutions as you scan them in, and that impacts your model significantly as well.
Yes, definitely. Sharon's actually expert number 2 in pathology AI on this panel. We've worked together on projects. So I think, oh gosh, I just lost my train of thought, guys. I just okay. Well, so
I have a question. There was a paper that came out in the Lancet this week, which I quite liked, on prostate cancer pathology, detecting and grading Gleason score, and amongst other things. Very impressive results from what I could read, with a decent ground truth. And I wondered if you guys had read it and had any thoughts on it.
So I've heard of that paper. I, embarrassingly enough, have not had a chance to read it yet. It's on my to-read list.
Okay, next week maybe.
Yeah.
Next week.
The next happy hour. We'll expect a one-page report.
From everyone,
yeah.
including the audience members. So do sign off if you need. No, I'm kidding. Going back to one of Hugh's points, I did see, I think it was a COVID paper in Nature, do a lot of pre-training, and not just pre-training on ImageNet. They pre-trained on ImageNet, then took that pre-trained model, pre-trained it again on a pneumonia TB task, and then pre-trained it again on essentially a weekly supervised task based on their COVID task. So looking at patches of lungs and saying the label and giving it the label of the overall data set. So it's actually 3 different pre-training steps for one component of the model, and the other component also had a pre-training step. So I realized, wow, there's so much you could do to warm up your model to get to the right place to then essentially arguably do fine tuning. It's arguably fine tuning at the very end. So it's kind of like the GPT-3 idea. And I think we will probably be seeing that more and more. And as models get larger, we could then do a lot more warm starts for a task we need.
I think particularly with COVID, you've got the issue where you have large public data sets, particularly in chest X-ray, with similar visual features to COVID. And so pre-training on those data sets makes a lot of sense. In a topic like, prostate pathology, you don't have that large public data set of similar features. And so pre-training means you still have to get your own data set of some sort. And maybe the benefit of pre-training is less obvious there in terms of time saved. But it seems to work well. We've been doing it in deep learning for years now. Pre-training helps. So, more public data sets that have more visual features would be a good idea.
And I think even in the core computer vision community, there's a lot of similar advances. This Sharon's example of pre-training multiple times really reminds me of this training with a noisy student example, where you have a student-teacher network that progressively get better over time. And I feel like I'm particularly excited to see some of these computer vision techniques really manifest themselves in medicine, to combine the computer vision experts with the clinical experts. And I think we're getting closer and closer to those times. But I think a challenge there will still be compute, because I think a lot of these papers come from institutions like Facebook AI Research or Google, where they're now counting their compute time in TPU years. So how much of that is accessible to individual labs, I think is still a question that needs to be answered. And I think that brings up even other points, like what are some of the environmental impacts of deep learning? And I feel like we haven't even started scratching the surface there.
Yeah, you raise a very good point there. And it's clear that for standard academic units to compete, it's getting increasingly hard now. And even renting that amount of time on a cloud cluster or something is prohibitively expensive. And go back to GPT-3, how long did they say it would take to train on a state-of-the-art GPU cluster? Something like 4 years or something ridiculous?
It was something, yeah.
Ain't nobody got time for that.
By the time you finish training.
Yeah, I mean, I'm looking at a project at the moment of reproducing a certain model in a slightly different in a medical data set, and looking at the team's GitHub page, they've got their model up there, and they say, oh, like, by the way, if you have one GPU, this is going to take 4 weeks to train, and that's with a smaller image than I'm going to be using as well. So, like, it is a real infrastructure challenge for academic groups. And even for startups, like startups also don't have the capital to buy TPU years worth of compute. The GPT would have cost millions of dollars worth of compute if you were buying it on the market. And no one has the capacity to do that. So who actually has the resources to train a large medical model? Well, the answer is, except for Google, if they really want to go for it, or the Google equivalents, no one has the resources to train a big enough model to cover all of our bases.
I'm trying to convince the NHS here in the UK. Sorry to talk about a socialized healthcare system to Americans. I apologize for upsetting you on this idea, but the government obviously funds everything we do, and I'm trying to convince them to put a massive pot of money aside to work.
That would be so cool.
And we get some access keys too, right? Because we're in this happy hour.
Only if the UK Trump trade deal includes it, I suppose. But, yeah.
I feel like I'm going to try to steer us away from that topic.
Very good, moderator. Very good.
For my personal sanity more than anything else. I think one question that I've been thinking about for the last 2 or 3 years, actually, and this is almost a perfect group to ask this to, is whenever I go to a medical meeting, and invariably in a keynote talk, I hear this term of a diagnostic cockpit of the future, where there will be clinicians, integrating radiology, they'll be integrating pathology and other subspecialties too. And I mean, that sounds great, having more information, but from a more human aspect, something that I've been thinking about is how can we actually build enough expertise in people to actually be able to get insights from these multimodality streams. And I would love to hear what the clinicians think about this diagnostic cockpit of the future that tries to fuse modalities from multiple different, subtypes. And maybe Judy, we haven't heard from you today, so I'll not to put you on the spot, but maybe we can start with you.
So actually, the person I think there was a workshop maybe last year, 2 years ago, where actually some experts met together about this diagnostic cockpit of the future, and Dr. Krupinski, who's actually my faculty mentor at Emory, was discussing what this would look like. And so I think it may be surprising, but I don't necessarily see this as personally, I don't see it as more of like a machine learning task in terms of, unless you're sort of relying on machine learning model to do the multi-data and multimodal data fusion. And so if I sort of look at you're merging like the clinical data and imaging data, and actually this brings to what I thought was different, something new that I learned since the last meeting was this idea and this concept of phenotyping, very popular in precision medicine. And I believe that the way I sort of synthesized it is this sort of multimodal data fusion, again, mostly, I think the papers that I reviewed are around the diagnosis, and then starting to feel what are subgroups and subtypes. And I just think that this speaks to a skill that's not very common, honestly, among machine learning experts, and may actually be more common among clinicians, which is informatics, which is just literally the basic foundation principles, even before you apply anything. One is, if you look at the data, like the inpatient data for EMRs, it's very, very messy. I mean, there's a lot of copy paste. I mean, it's almost like 95% is copy pasted. And then if you start to build this sort of model of the future, what we lack is what was the patient doing before they came to hospital. So you always have this unilateral view of only the sick portion of their work. And so, when I think gee, when I see you actually, maybe let me not use actually, when I see you goat, were you running around and eating all the grass before you got sick? Or are you now, when I see you when you're bedridden and sort of, with a lot of waste, what's a true representation of yourself? And so from a radiologist who actually does procedures, when I think of this data like system visibility, what I would like has nothing to do with AI even yet. It has potential, and these are some of the work projects that we're doing, is that in this hospital, like today, there are many patients who got sick and got an endoscopy and it wasn't successful and they didn't find any bleeding. And that those patients will be my patients sometime tonight, at 3 a.m. Why don't I have better visibility of this type of tasks? So that's even more of a system visibility, more than saying that when I'm looking at this chest x-ray, I can tell that 5 years ago, there was this chest x-ray and it may be in the same institution versus, and this patient had a biopsy and this was the pathology report for it and this is the pictures, and sort of where you're looking at a patient level information when you're sort of trying to interpret a study. And so lots of rambling, but I see this diagnostic cockpit, I think in the context that it was introduced was specifically around an individual patient. But I personally see a bigger impact when we have a better visibility into what is going on in the system. And I do really believe that operations support is a fantastic area to apply AI and machine learning and in medicine. But all these things, I think, completely they're introduced as new concepts, but usually in the past they usually have to when in the past they usually are very distinct from informatics, which is the fundamentals of what would be sort of required. But I think it's an interesting concept. But I'm curious to hear what other people think.
I think I totally agree with you in the sense that, we don't need to necessarily invoke advanced technology to, if we're talking about fusing different streams of diagnostic information, we already do it. It's a multidisciplinary meeting and they're really time consuming and human labor intensive, that you have to sit down with the specialists of each different diagnostic specialty and nut out all of the different ways to combine this information. And so the idea that you can somehow sort of bring in technology and easily make that data available to a single clinician in a way that will be useful to them, or even go further and get an AI system to do that fusion, it's a super hard task. And I can't imagine we're going to have a fully functional diagnostic cockpit anytime soon.
Does that change in how we train future clinicians?
There has been some talk about co-training radiologists and pathologists to be just sort of a diagnostic subspecialty. And I'm still kind of confused as to how that might even work. I mean, I don't know about you guys, but like it took me 5 years to get comfortable looking at X-rays and CTs and MRs. And I still, when I look at the histopathology slides that come up in the multidisciplinary meetings, I've got no idea. It's just purple splotches to me. I like to do double training, I think would be a really tall order. I think obviously there's some people cleverer than me who would want to do it, but I'm not convinced that that's the way forward. I understand though that Stanford, there is some kind of co-joint training in this. Am I right?
Not officially, I would say. I haven't heard of a named program for this, but we do occasionally share some trainees, right? So there may be very interested, let's say radiologists who want to come rotate on our service for about a week and just learn about the histopathology and how to correlate that with the gross findings that you see on radiology. But by and large, I think, I agree with you. I think people generally feel in those specialties that it's too much time, right? And too much training, I think, to try and gain expertise. There's sufficient expertise in two very different specialties. So if there were, if I could go back and do it again and there was such a specialty, I'm not sure I would want to do it. to be honest, right? That would be
Is
what,
it-
8+ years of training.
Is there a single physician on earth who's dual accredited in radiology and
Not that I know
pathology?
of.
Well, time for a first coming up. And maybe to quickly pause from this conversation, I have been told that our VIPs are incoming, and maybe the higher powers will somehow put them in.
They've left. They've left apparently.
They've left. Oh no. Oh, okay. Well, I guess we can continue training.
I'm so confused. What's happening?
Maybe if they come back, we'll just go straight to them. We'll cut what we're doing and jump straight across.
Go.
But I'm curious. So,
sorry.
oh, I was just going to ask Akshay. So the cockpit of the future, I mean, cockpit to me sort of reminds me of a plane cockpit, right? But I guess, have you seen a prototype of this? Has anyone on this panel?
Yeah, the full Minority Report. That's what it's going to look like.
And the
So like radiology now.
Yeah.
The closest that I've seen was a comparison of the actual cockpits from space shuttles, 20 years ago versus the ones that SpaceX sent out, where there's basically like 1% of all the different controls. I'm sure they're on the touch screens, but maybe in terms of a diagnostic cockpit, I don't think I have really seen any applications even close to that area. I think the closest that I've come across are some studies that try to link your EMR with your radiology images, or maybe potentially linking EMR to pathology. But I've never really seen a link between pathology and radiology in a clinical study. I know there's a lot of push in things like trying to register them together to see, whether imaging can predict pathology. But again, that's not necessarily my expertise. So maybe I haven't just looked into it too much more, but I think there's definitely a lot of very different challenges in trying to tease out semantic information from these multiple different data streams. And I don't think we're very close to that, but maybe that's just my own ignorance.
I've got issues around just the usability and the functionality of it. I work with a lot of startups trying to get their products to market, and we do a lot of usability studies and things, and radiologists just hate having anything extra to click, like even if it's just one button. So I think giving them like 1,000 things on the screen and go, look, you now have to learn what all these do, it's just not going to happen. I just don't see it. Things have to be automated to the point where the radiologist doesn't have to think about it.
I think there's a role for task shifting, though.
Potentially.
Yeah, task shifting. And the reason for that is, maybe not everything, but there's some components where, it's just like bone age, right? Of all the things that people want to take out, like have always produced and said we'll replace. I mean, I don't know any radiologist who I wouldn't miss reading them. Thank God I don't have to read them, but I wouldn't miss reading them at all. And there are some of these tasks that I would see sort of like a very, very potential AI tool doing as good as a radiologist. And and I do believe that some of these tasks would have to be minimal risk, and where there's no, so what if the contour wasn't as perfect, and I can live with it. And so now that risk is, and that sort of evaluating that is very variable from one radiologist to another. But I do think that I could see not a formal training model, but actually a place where you can task shift some of the work. So specifically, there's a project we're working on here where we have a very, very robust telepathology service. The pathologists rarely come to us when we do biopsies. And just determining if we have adequate samples or not is a tremendous task. If, just for us during the intervention, it means reduced reintervention rates and saves time for the patients. And so this is a fantastic place for shifting one of the people in the room to make slides and get, is the sample adequate or not? I don't know if that's important for the pathologist to know and feel like this is your, coming onto their turf. So I'd actually be curious to what Jean would say, but this wouldn't be requiring a lot of training, and you can teach pretty much anyone to do those slides, at least in my opinion, at least just for the sample adequacy, and you're in the right place, you know.
Right. So it sounds like what you're envisioning might be something, sort of like I wouldn't say teleconferencing, but something similar to that, right?
Yeah.
I think, it's going back to the cockpit idea. There probably won't be a universal cockpit, right, that works for all physicians, because obviously a radiology cockpit would be, it'd have to be designed to cater to radiologists' needs, and a pathology cockpit would cater to pathologists' needs. But I guess the closest thing that we have right now, right, and I wouldn't call it a cockpit, is Epic, right? So Epic,
Ooh,
the EMR system, we do have some customizations of it now for different specialties at Stanford, right? So you can customize your Epic for radiology or for pathology. And I guess maybe step one would be just doing things that make our lives easier, right? Just our day-to-day tasks. So for example, if let's say I'm a GI pathologist, and so I read a lot of endoscopic biopsies, and there's a lot of clinical information that I want to have, right, at my fingertips that's not readily available right now. And my resource for getting that is essentially the resident or the fellow. So they're the ones who, write down the endoscopy note findings and tell me what the clinical history is, because they've already looked in all of the notes, and they tell me, let's say if there's a mass, what the radiologic findings were, what the depth of invasion they thought, what they thought that depth of invasion was based on imaging. And so I want all of those findings, but I don't want to spend time looking for them in the EMR, because that takes quite a lot of time. And so I think, step one for a useful cockpit, I think for most of us, right, would be just to automatically know what information we want and to pull that for us and make it easily accessible. And, as Hugh had said, he doesn't like clicking around a lot. So it'd be nice if it could just show up, right? Or maybe have some kind of voice recognition system where I say, okay, I want to see the endo note, and it just pulls it up, right? Rather than me having to click to the endoscopy note tab and open it up manually. So maybe that could be step one for a cockpit, specialized for different subspecialties or specialties, and, something that makes our lives easier. But ultimately, I think, we're all interested in what AI can do for us. And obviously that's analyzing a lot of big data and seeing patterns, right? And let's say predicting clinical outcomes that we just can't do, even though we're already integrating all of these things, right? So we're doing what I guess we want a machine learning model to do ultimately, right? Look at the pathology, look at the radiology, look at all the clinical notes in the labs, and, figure out, well, what's the diagnosis? What's this patient's prognosis going to be? What kind of treatment will they respond to? And I think that's sort of, that's the power, right, of what machine learning can do for us.
Yeah, and I think we're heading globally, not just in medicine, towards a paradigm where everything that can be automated will be. And in medicine, you have to add it. It has to be automated safely. But with that, then comes, as Judy said, a transfer shift of control and power, and a change in the way that we all work and function. And what's really interesting to me is, and this is going to take it on a slight tangent, is that we're all focused on deep learning coming in to do these tasks for us. There are already completely intelligent systems that can do all of these tasks for you for pennies. They're called humans. They're just not trained clinicians. And so we in the UK use radiographers or technicians, or we sometimes just have healthcare assistants, and we train them to do the mundane, routine, automated tasks. But of course, unlike machines, they need pensions and salaries and holiday and all that kind of stuff. But I think without going down that route first and finding out what is automatable and divvied up between different sectors of the workforce, then trying to just dump machine learning straight on top and trying to solve the problems is maybe putting the cart before the horse slightly.
Yeah, I do feel like we are sort of in an era where AI is the hammer, right? And everything looks like a nail. And what we're trying to do is find as many nails as possible to hit with the hammer, but not really thinking about, well, does this nail need to be hit, right? Is this a good task? Do we really need an AI hammer for this nail?
We don't need AI. I'm going to drop the mic.
And Hugh, I'd love to learn from some of your experiences in looking at this from a regulatory standpoint and from an implementation standpoint. I feel like we're seeing a lot of, FDA-approved, CE-marked algorithms out there, but I think a challenge that we haven't really considered is how do we actually integrate it into how we perform medicine? So for example, if we have some sort of clinical decision support system for chest X-ray analysis, how does that change the reading room? How does that change how a radiologist performs their workflow? Do you get the prediction before you read it? Do you get the prediction afterwards? How do you see that actually being implemented at the point of care, essentially? Or everyone else too.
You raise a really good point. I mean, the regulators are only interested in the bits of the systems that actually change clinical pathways of individual patients. They don't care so much about the back-end infrastructure. So for instance, PACS is not a regulated medical device in any shape or form. It's a storage archiving system, but it's absolutely fundamental to everything that we do. And when PACS was first invented and rolled out over 20 years ago, people were like, whoa, what is this thing? I don't understand it. And there was no real regulation around it. But to answer your question, there is a kind of gray zone in the regulatory framework between this is the bit that's potentially clinically dangerous, and then this is the bit that's not dangerous at all, but actually impacts most on what the radiologist or the pathologist is doing in their workflow. And you could argue that they're both equally as important, but the regulators tend to just focus on the clinical efficacy and the safety rather than exactly how it interacts with the workflow. There are regulatory standards for usability. So there are international standards. 62366 is the international standards for usability of medical devices, which companies should go through. But by and large, it's much less of a focus. And I'd like to see a bit more of it, for sure. And the second thing to add, just very briefly, is that we're going to end up in a situation in a few years' time where we're literally going to have 1,000 FDA-approved algorithms. How are you possibly going to integrate them all into any one single radiologist workflow? It's going to be next to impossible.
I think one of the sort of things you're talking about there, usability as a standard or a regulatory framework is not the same thing as usage. And, so far we haven't been doing real world testing of AI. To Akshay's question, how people actually use the system is not tested before these products go to market. And so we've seen in the past lots of systems, we talk about this all the time, we've seen in the past systems that go to market with approvals for certain levels of performance, and humans use them differently than expected, and they perform differently than expected. I always talk about mammography as the key example, but another really obvious example is voice recognition. That we know the word error rate of voice recognition in radiology report transcription, for example, but it turns out that in the real world, typists also edit reports. They don't just transcribe reports. And so they pick up some of your errors and get rid of them. And the reality is that when you put these things in practice, radiologists produce more errors simply because they're not as cautious, because they're used to typists, and the errors can be really significant. And so how people use systems, in my mind, is actually far more important than how usable they are, or even how you're presenting the results. That actually testing in practice what people do with the results is the key problem. And we don't have it yet. We are seeing a development of a new research field, which has essentially been the human-computer interface field till now, but it's become urgent. So, before it was an important field that people cared about from maybe an improving performance issue, but now it's a real safety problem. And hopefully this field is going to really, really expand in future and solve some of these issues for us.
It's the unsexy side of AI, I suppose, isn't it?
And it's interesting, we keep talking about PACS in the radiology concept, but recently I've heard that the concept of PACS doesn't necessarily entirely exist in pathology. Maybe Janie, do you want to just talk us through some of what your experience has been along those lines in terms of a centralized repository where you can find all the information that you need to act?
Sure. So I think that's one of the major challenges for our specialty right now. And there are certainly startups that are trying to address that, but we're very siloed, right? So every institution has its own, essentially, I guess, PACS, right? Here it's called PowerPath. Another big company that's also from SunQuest is CoPath, but they all work pretty much in the same way, and every pathology lab has some version of that. They don't communicate with one another. They don't even communicate with Epic very well, so the clinicians can't see our pathology reports as they are in there. So it is a huge problem right now. My experience at every institution that I've been at is it's a completely walled off separate system that doesn't talk to the rest of the hospital. And so that makes it extremely difficult for us to sort of, obviously we can't deploy any algorithms, right, in that system. So right now we're actually, we're going completely digital for our primary diagnostic workflow. And we're using a vendor's image management system. And that, again, is a completely closed system, partly just for security issues, right? Because there's PHI in there. But it makes it difficult, I think, to collaborate with other institutions. And right now, we have no way of actually running any of the models that are developed at Stanford in that system. So it's a challenge that I think we're all aware of, and there are a lot of companies that are trying to address that.
And perhaps
So I think that actually, again, this is where actually, I don't know any machine learning. I know you're an educator to the courses that, especially when they do machine learning for health, that teaches like basic informatics stuff. And that was also a big learning curve for me when I moved to doing, radiology informatics, because there's all these domain things that you have to understand. And so what some of the concepts that have come up in the recent years is, so a PACS, for the people who are not radiology experts, is this imaging database archiving system. And so there's something called enterprise imaging. So with the amount of content, so the ophthalmologist is taking images of the retina, the GI doctor is having endoscopy. And so you can imagine if you're looking, as a GI pathologist on this imaging, so in the form of the cockpit of the future, you'd see the last clinical note maybe of the person who ordered that study. And these things, by the way, to the physicians are what are low-hanging fruits, but they remove such a pain point, and before even you can go to something new. But so you can see the imaging that they've had, you can see the endoscopy imaging at the same time, and then you can see the pathologist imaging. And so this concept of unifying this image storage, and you can also imagine that if I'm in the clinic and there was a lesion on the skin, I took a picture, the dermatologist, so all these ologists are unified in this thing called the enterprise system. Now it's the challenges of that has been that enterprise imaging, now you have to think about, if I'm reading 100 studies in my shift, I don't want to see the pathology images. Like, I don't want to see all of them, And also in radiology, we're very lucky because of the DICOM standard that everything is sort of, there's a little bit more of standardization. So everything appears as a study with an accession number. Now you have to transform all these random images, and boy, people can be very photographic, and so to sort of this imaging, and then starting to restrict analysis, and so analysis. And so I think that unfortunately still one is that healthcare institutions have invested so much money into these systems that you will not, these systems cost millions of dollars to install. And it doesn't matter those painful things that we say we deal with every day. In fact, they're normal to us. that, well, in any other place would be absolutely unacceptable. And so I would say if this is something like you're working in this space, you need to understand the foundations. And I believe the concept of enterprise imaging is one of those. And the best resource to review this is actually on the Society of Imaging Informatics in Medicine, SIIM, where it's not just radiology, but sort of this concept of enterprise imaging that you can learn from.
I think we have our special guests here. I think Sandra is on the line. Hey, Sandra.
Hello, how are you?
We're doing well. We're excited to see what you have in store for us.
Yeah, so thanks for having us. I apologize, our other guide was having some issues joining your webinar. So I was able to come on down, and I'm in our chicken and turkey yard. So let me go ahead and turn our on for you guys, and I can show you what I'm looking at here. So my name is Sandra Lawrence, and I'm the development director here at the Sweet Farm Foundation. And we are an animal sanctuary and an heirloom vegetable and flower farm located in Half Moon Bay, California. And we are home to 130 rescued farm animals. And the majority of our residents here we've got about 80 rescued hens that have been rescued from all sorts of different sorts of situations, backyard breeding operations, factory farms, and so forth. We also have our larger turkeys here that have been rescued from some factory turkey farms. We've got Caleb, our large male here, and then we've got his 4 ladies. We've got Isabel, Arabella, Ethel, and feisty Fiona right here on the left here. And these are your typical big-breasted white turkeys. So your traditional Thanksgiving style turkeys. And so they're all enjoying their afternoon out here in our turkey yard, our chicken yard. Caleb's walking his ladies around and strutting his stuff out here in our chicken yard today. So, but a lot of our other ladies here and our chickens, they, like I said, come from lots of sorts of different backgrounds. A lot of them come from backyard breeding situations where they are retired hens that they're no longer producing the amount of eggs that someone might want them to produce. So they end up in animal control situations. And then they end up at a sanctuary. Luckily for these ladies and some of our gents that are crowing, they will get to live their lives out here at the sanctuary. They're very social. They have up to about 30 different vocalizations that they use to communicate with. They also have a very complex social hierarchy. And so you will typically see the same group of hens hanging out with the same set of ladies. And each group of hens also has their rooster. And so each rooster here at Sweet Farm has anywhere between 8 to 10 roosters, or I'm sorry, 8 to 10 hens that are kind of like his set of ladies that are his, and he protects and he watches over. This is Gregory's coop. This is Gregory here. He's one of our larger roosters. And they will always hang out together. And they're they're enjoying the shade here. This is Evelyn, the beautiful black and white one here. And they're just kind of enjoying the afternoon in the shade underneath the coops here from the sun. So yeah, so we have about 10,000 square feet for our birds here in our area. And typically in a factory farm setting, you would see anywhere from 10 to 12,000 birds stuffed in this type of area. So in a 10,000 square foot area, they have very little space to call their own. Now, our birds, they have the safety of this coop that they can go up into at night. These coops are all predator proof, and they have nesting boxes that they lay their eggs into. And so we get all sorts of different color eggs here at Sweet Farm. And the color of the egg will depend on the color of the earlobe of the chicken. So each chicken has a tiny little earlobe, and they will have a color, and that color will determine what color egg they lay. So does anybody have any questions?
No questions, but it looks like a great day to be outside in Half Moon Bay. Thank you for the great tour. This is a nice distraction for us.
Not a problem. This is Susu. Susu's our smallest rooster. He is a bantam frizzle rooster, and he is small but mighty. So he's one of our littler guys here. But Susu.
Yeah, very pretty. Well, thank you for taking the time and showing us around the farm. It was really nice to see them having space to run around and be comfy.
Thank you guys so much for your support today. I'll let you guys get back to your conference. You can learn more about us on our website at sweetfarm.org.
Thank you so much, Sandra.
Thank you.
Thank you.
Thank you.
All right. Thank you.
Yeah.
Bye-bye.
That was a nice little distraction.
Well, wasn't expecting that at all.
I don't know if anyone remembers the specifics, but at least 2 or 3 years ago, I remember reading a study where pigeons were taught to read mammograms, and they did surprisingly well. So maybe free-range chickens reading chest X-rays could be next. Who knows?
But the pigeons cheated. You see, they were only trained. They were only trained on mammograms where there were macrocalcifications, which look like the seeds that they peck off the ground. So I wrote an article about it. Yeah. I wrote an article about it at the time. So
look, I don't know if that's true. The pigeons are widely used as models of human visual systems. So in cognitive neuroscience, pigeons are a widely studied model of human perception. They can recognize the letters of the alphabet. They can recognize emotions on faces. They can discriminate between Van Goghs and Monets. There's a whole range of things they can do. And there was a paper that came out that said, yes, they can learn to do radiology and pathology reasonably well within a fairly short space of time. So, yeah, I mean, it's an interesting, I think it is relevant to AI. I actually use this example a lot because it gives you a really good idea of what it means to be a good pattern recognition system without knowing anything about the world. And with that example, you can think about how AI systems can fail. The sort of problems that you expect pigeons to have with recognizing things. If the calcification is not there, they're not going to recognize the cancer. Then the AI system will have a similar problem trained on a similar data set.
it certainly would be cheaper, I suppose.
Depends on how many chickens or pigeons you need. We'll have an ensemble of experts.
The thing is, you can't eat them afterwards. That's the problem.
Yeah, I'd be maybe less happy there. In the interest of time, since we're just past the hour, I guess in our slowly building tradition, I do want to end by at least having one question for everyone here. And maybe this is specific to an event that we have coming up next week, which is the AIMI Symposium, which is happening on Wednesday. If you haven't signed up, please do. We have a great list of speakers. Registration is free. And I'm really looking forward to the event. And the question I wanted to ask here to everyone is, whose talk are you most excited about? and why. Maybe a one-sentence description. And it can't be your own if you're speaking. It has to be someone else. Maybe we'll start with Luke. You're first on my screen.
Oh gosh, I have withdrawn from the event. Unfortunately, my sleep schedule plus baby has been a challenge. Who am I most interested in seeing? I don't know. It's a really good lineup of speakers, and I'm sure there's going to be a pretty wide-ranging set of things. I think, in general, I've been most interested in seeing people speak about the issues of, bias and particularly the social implications of using AI. So the talks that are going to be on those topics, I think, are going to be my go-tos.
Yeah, we have a whole session dedicated to that, and I feel like I'm woefully uninformed about that, so I'm really looking forward to learning more from the experts. Maybe we can go to Judy next.
I'm gonna follow your cue last time where you asked your own question, and so I think I am looking. I'm also more interested in the areas of around explainability. Actually, that's been something that I've been spending quite some time thinking about, and especially explainability. I know this is not the big thing for. In the terms of the domain experts, so you can imagine beyond saliency maps or something like that. And Luke is really a leader in this, where he talks about, and I hope one of the future webinars will do this, and where we go through like this group analysis, subgroup analysis, failure analysis, and I think that's such an important way that I don't feel that the techniques are there yet in terms of progress. But I'm also looking forward to the fire chat guest, Andrew Ng. And because one thing is that I will be asking him the questions. And so I'd be curious to hear what other people on the panel would like to ask him about the state of AI, of AI in healthcare, and also the attendees. If you could post the question that you want to ask, sort of this, I'm not going to say Godfather, because that's actually pretty controversial, but this giant, one of the giants of AI generally. And so maybe just tag on that question to the other panelists and to people on the live stream.
Yeah, so feel free to post your questions either on the YouTube or feel free to email the AIMI Center, and we'll try to make sure Judy gets your question if you do have one question. Maybe we can turn to Hugh.
So Eric Topol is always entertaining. He's a good friend of mine. I worked with him for a year on a project over here when he came to the UK. And also, I think the one that I've highlighted I'm going to stay up the latest for, because I have to go to bed at some point, is Jeremy Howard. He's talking about self-supervised learning techniques, which I think is going to be very interesting.
Jenny?
I think for me, I'm quite excited about the topic of how to bridge innovation in AI and actually translate that into improvements in clinical care. So I'm really looking forward to Vivian Lee's talk.
Mm-hmm. Sharon?
I have many questions for Andrew Ng. Just kidding. He's my advisor. I talk to him a lot.
Meeting with him.
I'm really excited. I'm going to help moderate this one with Daphne Kohler and Eric Topol. I'm really curious to see kind of how they interact. I'm also particularly interested in, I haven't talked to Daphne in a very long time, so I'm very excited to hear what she's up to with life extension and just all her work in general right now. Yeah. What about you, Akshay?
Yeah, I don't want to steal your answer, but I was most excited about learning from Daphne's experiences coming from computer science and using machine learning in a realm that I don't know too much about, drug discovery. I think I'd love to learn about the journey as well as about the field. So I'm quite looking forward to that. So it should be
There's also a talk on how to please the regulators by some English guy I've not heard of. But I might check that one out.
Looking forward to that. All right. Well, thank you to all our panelists once again for joining. It was a really fun session. I look forward to all these questions and answers that we get to chat about, and look forward to probably seeing everyone next month. But
Awesome.
until then, have a good night or a good morning, depending on where you are, and enjoy the weekend. And maybe see you on Wednesday.
You say
See
next
you
month, but
later.
you say next month, but it's already August here.
Oh, well, I'll see you tomorrow then.
I think
See
we
ya.
need actual goats to go to a meeting, guys, next time. Okay, no pressure, Stephanie.
All right.
All right.
Bye, everyone. Thanks again for your time.
Bye. Thanks so
Thank
much,
you.
Akshay, for hosting.
Thanks for joining. Bye.
The recording has stopped.